We want to solve the given equations with rational exponents. To begin, we have x to the power of 3/2 equals 8. Recall we want the solution to be in the form of x equals some value, where x is raised to the first power. Right now we have x raised to the 3/2 power. So one approach would be to raise both sides of the equation to the reciprocal power. However, sometimes these equations have more than one solution, and if we always just raise both sides to the reciprocal power, we're probably not going to notice when there is more than one solution. As a result, I will show how to solve for x in 2 steps. And first, raise both sides of the equation to the power of the denominator of the exponent, which for the first equation means we will begin by squaring both sides of the equation. Again, on the left, because we have powers raised to powers, we multiply the exponents, and 3/2 times 2 is equal to 3. We now have x cubed equals 8 squared. And at this point, if x was raised to an even power, we would have a positive and negative solution, but in this case we have x raised to an odd power, and therefore we will only have one solution. We now want to raise both sides of the equation to a power so that we have x to the first power on the left. So now we'll raise both sides of the equation to the power of the reciprocal of 3, which is 1/3. Multiplying the exponents, 3 times 1/3 is 1, giving us x to the first, or x, equals on the right side, 2 times 1/3 is 2/3, we have 8 to the 2/3 power. Notice we could have solved for x in one step by raising both sides of the equation to the power of 2/3. And now we'll simplify the right side by writing 8 to the power of 2/3 in a radical form. Recall the denominator is the index and the numerator is the exponent, and because 8 is a perfect cube, let's write 8 to the power of 2/3 as the square of the cube root of 8. And because 2 cubed equals 8, the cube root of 8 is 2, giving us x equals the square of 2, which is equal to 4. The equation has one solution, it is x equals 4. For the second equation, we have x raised to the power of negative 5/2 equals 32. Again, we could raise both sides of the equation to the reciprocal power of negative 5/2, which would be negative 2/5. But again, let's go ahead and do this in 2 steps. Let's first eliminate the denominator from the exponent by squaring both sides. Multiplying the exponents on the left, negative 5/2 times 2 is negative 5, giving us x to the power of negative 5 equals 32 squared. Again, we don't have an even exponent, and therefore we won't have 2 solutions. We now want to raise both sides of the equation to the reciprocal power of negative 5, which is negative 1/5. Simplifying by multiplying the exponents on the left, negative 5 times negative 1/5 is 1, giving us x to the first, or x, equals, on the right we have 32 raised to the power of negative 2/5. Before we simplify, let's write 32 to the power of negative 2/5 using a positive exponent, which would be 1 divided by 32 raised to the power of positive 2/5. And now we'll convert to radical form. We have x equals 1 divided by 5 is the index, 2 is the exponent, and because 32 is a perfect 5th root, let's write 32 to the power of 2/5 as the square of the 5th root of 32. Because 2 to the 5th equals 32, the 5th root of 32 is 2, giving us 1 divided by the square of 2, which equals 1/4. Again, we have one solution, and the solution is x equals 1/4. In the next example, we'll see an equation that has 2 solutions. I hope you found this helpful.